if cosecant of theta is less than 0, well, cosecant is 1 over sine. That has to be less than 0. Probably the easiest thing to do here is to think about it. 1 is always positive. So if you're going to have less than 0, what does sine have to be? It has to be negative as well. So then sine of theta would have to be less than 0. Simplify cosine squared of 4x plus 1 minus sine squared of 4x plus 1, or something like that. They're giving you, yes, so equal to, in this case, let's say cosine of b. Focus on what is this going to be? What is the b going to be? I was just going to simplify the whole thing, but yes, we'll get there either way. So if I started with cosine squared of 4x plus 1 minus sine squared of 4x plus 1. The first thing I'm going to do, though, is I'm going to simplify this because I see that this piece right here is the same. And so I'm going to think of this as cosine squared of something minus sine squared of something. And does that look familiar? Oh, not Pythagorean theorem. So this minus, it's not the Pythagorean identity, even though it looks, that's the real tempting thing to jump to, but it's not because it's subtraction. So you're going to need to look at your identity sheet and find something that has cosine squared minus sine squared. Well, in our case, it would be cosine of 2 theta, yes. So it's cosine of 2 theta. So whatever, whatever theta is here, this should be 2 times that. And if I look at what substitution I made, I said that theta was equal to what? 4x plus 1. So then we need to know what 2 theta is. So 2 theta would equal, so 8x plus 2. So then this expression right here, using this pattern, I know that this follows the same pattern. And so it will be the cosine of twice whatever was in here, which is 8x plus 2. So then if they were looking for b, then your answer would be this, okay? That would be b. So this, whatever's inside the cosine, that would be b. If they're looking for you just to simplify the whole expression, so if I hadn't given you this piece and I just wanted to know what it was equal to, then my answer would be this. Well, yes, you're going to have to practice it. Yeah, you're going to need to practice it, but yeah. And you can always email me if you get stuck. Okay. Yeah, hopefully I can write the questions in such a way that it's going to tell you exactly what you need to put in the answer box. Okay. All right, so you're welcome. So then the question that Lisa and Jaya had, you guys are going to have to clarify this to me because I obviously misunderstood it the first time. Let's suppose that I told you that cosecant of x is equal to, let's do 13 over 15, or no, 13 over, that won't work. 13 over 11, okay? And for x in quadrant 2. We'll go ahead and find cosine of 2x, and we'll find, that'll be one of them, and then we'll find tangent of 2x. And I think that hits all of the areas where people might get stuck. If cosecant of x is 13 over 11, what else do I know? A reciprocal is sine. So then the problem becomes sine of x equals 11 over 13. Then this problem is very similar to what you guys were talking about. And the first thing I'm going to want to do is figure out what cosine of 2x is. Well, there's 3 identities I can use for cosine of 2x, and that's what makes this one a little harder. But I only have sine of x. Which identity only involves sine of x for cosine of 2x? Yep. Yep. Okay, perfect. Okay, so then this one I can calculate by taking this, and then 1 minus 2. I'm going to square whatever the value of sine of x is, which in this case is 11 over 13. I need to make sure I follow the order of operations. The biggest, I would say, basic error that students make is not following the order of operations. So I need to square this first. And I see that this is 13 squared. So 13 squared is 169. So I'm actually going to write 1 as 169 over 169 right away. And then this would be 2 times 11 squared is 121. Oops. And then 13 squared is 169. So then I have 169 minus 242. 169 minus 242. So that's going to be negative 73. This would be the exact answer. But if they asked me to enter it as a decimal, then I would need to approximate that. So this would be exact form. Oops. Exact. And then an approximate would be whatever I get when I divide that out. And don't forget when you're doing these that you should use at least 4 decimal places or more. So let's see, negative 73 divided by 69. Negative 0. Oh, so it'd be 4320 like that. Okay, there we go. Okay, so then that's our approximate answer. That's our exact answer for this part only. Okay, so we've just done this part. Now for tangent, so what is the, remind me of what the identity is for tangent of 2x in its normal form. I'm pretty sure it's like, yeah. Yeah, so you have to know tangent out of this. Okay, and we knew that sine of x was equal to 11 over 13, but we're trying to find tangent of 2x, which we know is 2 tangent of x over 1 minus tangent squared of x. But the other way that I could solve this problem, just so you know, there is an alternative. I could also do sine of 2x over cosine of 2x, which I already have cosine of 2x. But I don't think there's an advantage either way, because in this one, you're going to have to find both sine and cosine. In this one, you're going to have to find tangent. So either way, you're going to have to find something. So let's go ahead and find tangent. And the way that I'll do that is by drawing it in my quadrant where it is. Make sure you're in quadrant 2, very important, because they told us that. So our angle X is in quadrant 2. What sides do we know based on what we have here? So opposite and hypotenuse, okay? And then I can use the Pythagorean theorem to find the X value here, which reminder that this X is not the same X as our angle, right? So over here, we're talking about X and Y as coordinates on the coordinate system. Here, we're talking about X as an angle theta, okay? So they are not the same X, even though they look the same. That's the downside of using, that's why we usually use Greek symbols for angles, because it simplifies that issue. If we did the Pythagorean theorem here, we'd have x squared plus 11 squared equals 13 squared, so 169, 121, x squared. So x squared, let's see, that's 48. Take the square root of both sides. Don't forget, plus or minus, very important. Probably the biggest mistake people are going to make in this problem. And the square root of 48 simplifies, because what perfect square goes into 48? So I'll show you a trick. Just find any number that goes into 48. And yes, it is 16, but I'm still going to do this. What's any number that goes into 48? 2. Okay. Any number that goes into 24? 12 and 2. Okay. Any number that goes into 12? 6 and 2. And then that would be 3 and 2. Now, if I look at what I've got here, every time I have a pair of factors, that's a perfect square. So I have a pair of 2's right here. I have a pair of 2's right here. 2 times 2 times 2 times 2 is 16, okay? So then I could rewrite, oh, I'm not going to give myself enough room there. I could rewrite this as the square root of 16 times the square root of, and the only factor left over is a 3. And then the square root of 16 is 4. That's square root of 3. I'd have 2 times tangent. And what is tangent of x going to be? Yes. So we're in quadrant 2. So it's negative x value because it's x. So in quadrant 2, x is negative. So then I'm going to have, but what is tangent? There you go. Okay. Yeah, good catch. Okay, and then 1 minus, and down here, the sign doesn't actually end up mattering, but you should still do it accurately, of course. So then when we calculate this out, I'm going to end up with negative 22 over 4 root 3 in the top. In the bottom, well, I know 4 root 3 is actually the square root of 48. So it turns out that simplifying this, I want you guys to note here, I simplified it to remind you how to do it. But in many of these problems, it's actually more expedient to stop here, because it's way easier to square that. Okay, but it'll be easier for rationalization purposes to have this. Okay, so even though I put the rationalized version down here, when I come to this one, I'm going to use this one, because square root of 48 squared is just what? 48. So I'm going to write that 1 as 48 over 48 minus, and then I'm going to square this, so it'd be 121 over 48. Uh-oh, 48, there. And so then I have negative 22 over 4 root 3 over negative 52. So is that 73? Okay. And we're almost there. Almost there. Now you could just plug this into your calculator if they ask for a decimal. If they ask for an exact answer, then you'd need to obviously leave it with the radical. But let's erase some stuff here so we have some room. So now we've got this. How do I evaluate that? Copy dot flip. So negative 22 over 4 root 3 times 48 over negative 73. Well, I think the negatives are going to cancel. There. So those are going to become positive. 4 and 48 reduce. So it'd be what, 12? So now I have 22 times 12 over 73 root 3. And how do I simplify that? There you go. Okay. Now, once again, if they only wanted a decimal, you could have gone back here and just plugged it in your calculator. Just make sure you follow the order of operations correctly. And that's the big problem. I find that people, when they take this and put it in their calculator, get the answer wrong 75% of the time because they forget parentheses for fractions and for grouping symbols and all that kind of stuff. Okay, and then if we multiply that out, I'm going to have 3 there. And the reason I left it like this is because then I can easily reduce those. And so 4 times 22 is 88. And then 73. And I think that would be our exact answer. And then you could go to a calculator and figure out what that is approximately. Okay, so what you do process of elimination here, because this is really saying sine of x is greater than 0. Whoop. Less than 0, sorry. Okay, so sine of x is less than 0. That means the 2 quadrants where that could happen would be here and here. But cosine is positive. Okay, so for sine, I have those 2 possibilities. For cosine, which 2 possibilities do I have? Quadrant 1 or quadrant 4. So what is the quadrant I have to be in? Quadrant 4.